Hello students, good morning. Today we will discuss NCERT solutions from matrices. So in today's class I will explain you the basics of the matrices as we have already completed exercise 1 and 2. So in the next exercise we will discuss about the transpose of a matrix. So it's a very important concept. Generally questions are being asked from this one particular portion. So I will explain you how to find what is transpose and how to find it and what are the properties of the transpose of matrix. Matrix multiplication we have already done in previous exercise. Now transpose of matrix, suppose any matrix is given. So in simple language, transpose is nothing. It is just changing rows into columns and columns into rows. That's all. Suppose any matrix A is given like this, you just see the order of this matrix, it is 3 into 2 matrix. So to get its transpose, it is expressed in some books by A dash and in some another books by AT. AT means transpose of A. A dash is also transpose of A. So what will happen in technical language, if any matrix is given Aij m into n, its transpose will be, its element will become Aji and order will become n into m. How it happens, you just see. Suppose a matrix A is given, you see it is a matrix of 3, 1, 2, 3 into 2 order. So to get it transpose, you make first row as first column, 3, 5 is first column, second row as second column, root 3 and 1, third row as third column. So if we change rows into columns, so the new matrix, the order of this matrix is 3 into 2 and new matrix is now you just see it is 2 into 3. Position of elements also changes. This element is A21. In this matrix now it will be A12. You see this element is A31. In this matrix it will be A13. So Aij element of a matrix will become Aji element in its transpose. If order of a matrix is 3 into 2, its transpose is 2 into 3. Keep it very simple. Only you have to change rows into columns, means your first row will become first column, second row will become second column, and third row will become third column. That will be the transpose of a matrix. That's all. Now we'll discuss few properties of transpose of matrix without any proof. If we take transpose and again we will take transpose of the same, means transpose of transpose. Okay, like we take the transpose of a matrix, that is A transpose, and we again take transpose of this, so you can easily understand you are going to get the same thing. Like in this I have taken, this is a matrix A, I have taken transpose of this, this is A transpose. Now if I again take transpose of this, so you are going to get the same matrix A again. So transpose of a transpose is equal to A. Second one property, if you multiply a matrix by any number and you take the transpose, the number will not change anything. It can be written as transpose of Ka. Transpose of K, what's the meaning of transpose of K? We have multiplied A by K and then we have taken transpose. Its meaning is A is multiplied by K and then we have taken transpose. It will be equal to K into A transpose. You first take the transpose and then you multiply it by K. It is one and same thing. Means you are first multiplying the matrix by any number and then you are taking transpose, or you take the transpose and multiply the matrix by any number. You are going to get the same thing. This is the property number 2. Third and fourth property will use transpose of sum of two matrices A plus B transpose is simple. It will be A transpose plus B transpose. So learn this property also. And the last one is in this order will change transpose of A into B transpose. That would be equal to B transpose into A transpose. Okay. A plus B transpose is A transpose plus B transpose, but A into B transpose is, in this order is reversed, you just see it is B transpose into A transpose. So on the basis of that we can do the questions easily. Like in example number 20, it is given a matrix A is given and B is given. Want to verify so many things. A transpose whole transpose is equal to A only, so we can easily do it. Similarly, you have to verify A plus B transpose is equal to A transpose plus B transpose. So I'm not going to explain any one of them. I will explain in the exercise because these all are very simple questions. So from the NCERT, you can try yourself. Like transpose, you can take easily. Suppose it is given A, so A transpose is nothing. You just change your first row will become first column, and second row is second column. You again take the transpose, so what will happen? Its first column will become first row. So you're going to get the same thing. Now this is a very important topic, and generally we get the question in the exam from this topic: symmetric and skew symmetric matrix. So in the simple language, I will tell you, if you take the transpose of a matrix and you get the same matrix again, same matrix again, means the transpose of a matrix is equal to matrix itself. If you take the transpose and you get the same matrix, then it will be a symmetric matrix. If A transpose is equal to A, then it is a symmetric matrix. In technical terms, I will explain you the conditions to get this one thing A transpose is equal to A. You see this one particular matrix A is given. You take the transpose of this. Just calculate transpose of this. You are going to get the same matrix again. So you can say it is a symmetric matrix. Symmetric matrix. So the essential condition for a symmetric matrix we'll calculate later on. First, we'll define now skew symmetric matrix. So in skew symmetric matrix, we'll get A transpose if it is equal to minus A. Then the matrix is called skew symmetric matrix. Means if A transpose is plus A, then it is a symmetric matrix. If A transpose on taking transpose, you get the negative of the same matrix, then it is called skew symmetric matrix. All right, in skew symmetric matrix condition is there, and this question is generally asked in the examination. That is why I am explaining this question. In skew symmetric matrix, AJI will be equal to minus AIJ. AJI equal to minus AIJ. And AIJ is 0 for all the values for which I is equal to J. For or I equal to j, I will explain the meaning of this. Aij is 0 for all the values I equal to j means diagonal elements. Only for diagonal elements I equal to j. Your diagonal element A11, A1, A22 and A33 etc. will be 0. All the elements for which A11 is equal to A22 means these are the diagonal elements. So in a skew symmetric matrix, always diagonal elements are 0. And in skew symmetric matrix, your AJI is negative of AIJ. What's the meaning of this and how to form it? I will explain over here. How to prepare a skew symmetric matrix using the above properties which I just explained. That AJI is equal to minus AIJ in a skew symmetric matrix. And second condition is diagonal elements should be equal to 0. So I want to prepare a skew symmetric matrix, you see. Suppose 3 into 3 order skew symmetric matrix I want to prepare. So these diagonal elements I will take as 0. This element you know it is A21. It is 2. Then A12 will be minus 2. This is the condition. Suppose this element is 1. This element is A31. So A13 will be minus 1. Suppose this element is minus 4. What is this element? This is A32. So A23 will be plus 4. Now you just take transpose of this matrix. You will get the negative of itself. So condition to get skew symmetric matrix is very simple. In a skew symmetric matrix, your all diagonal elements should be 0. First condition. Second condition, each element Aij must be equal to minus Aji. Okay, means A12 will be minus A21, A13 is minus A31, and A23 is minus A32. Like these conditions will be applicable in case of skew symmetric matrix. In symmetric matrix, you are going to get the same matrix again. So in symmetric matrix, Aij will be equal to Aji. For symmetric matrix, condition is in symmetric matrix, Aij is equal to Aji. then your matrix will be symmetric. You can prepare yourself. Means element A12 will be equal to A21, A13 will be equal to A31, A23 equal to A32, and for diagonal elements in symmetric matrix, no condition is applicable. Diagonal elements can have any values. Only condition your Aij must be equal to Aji for a symmetric matrix. For skew symmetric matrix, your Aij is minus Aji and diagonal elements are 0. Alright, so I will prepare a symmetric matrix using this one particular property, that Aij must be equal to Aji to get a symmetric matrix. Suppose in exam you ask, give one example of a symmetric and skew symmetric matrix, then you need not to learn it. You see, I've taken this is 1, 2, 3. All right. So this is A12. If it is a symmetric matrix, A21 is also 2. This is A13, so A31 is also 3. On diagonal, you can put any element, like this is -5, -6. It will not going to affect. Now, this element is A23, suppose 7. So this will be also 7. Now, if you will take the transpose of this matrix, you are going to get the same matrix again. Change the rows into columns, you're going to get the same matrix. So in a symmetric matrix, the essential condition is Aij is equal to Aji, means A21 is A12, A31 is A13, A23 is A32, and diagonal elements can have any value. Suppose you want to prepare a skew symmetric matrix, so what will I do? First of all, I will put the element 0 as the diagonal elements. Suppose this element is 1, so this is -1 now. This is 3, this is -3 now. This is 2, this is -2. Because in skew symmetric matrix, your diagonal elements are 0 and non-diagonal elements Aij is equal to -Aji. So in this way, we can write the symmetric and skew symmetric matrix. I hope you understand this thing. Now next thing. Theorem 1, that suppose A is any matrix is given, then we can prove that A plus A transpose will be always symmetric matrix. Suppose you want to get a symmetric matrix, any matrix is given, we'll add its transpose in this, whatever you will get will be the symmetric matrix. So sum of a matrix and its transpose is always symmetric, that we'll prove. And the difference of a matrix and its transpose is always skew symmetric. Any matrix A is given, to get a symmetric matrix, we can add A transpose in this. Whatever result you will get will be a symmetric matrix. If any matrix A is given, if you subtract the A transpose from this, whatever result you will get is a skew symmetric matrix. We'll prove it first. So see first, suppose A is any real number and square matrix A is given. So we will prove that A plus A transpose is symmetric. So I have taken B as A plus A transpose. So to prove symmetric, we know that we have to take the transpose of a given matrix. If it is equal to matrix itself, then we can say it is symmetric. Because definition of symmetric is the transpose of matrix is matrix itself. So B is given equal to A plus A transpose. So now we are taking the transpose of this. Left side we have taken it as B transpose, right side it is A plus A transpose whole transpose. Now we'll use the property that A plus B transpose is A transpose plus B transpose. So it will be equal to transpose on this plus transpose on this. Over here it is double transpose on A transpose whole transpose. So that property we have already used, A transpose whole transpose is A only. So now it is A plus A transpose only. So we started with A plus A transpose. Okay, we solved whole transpose on this and we got the same A plus A transpose again. Means the transpose of A plus A transpose is equal to A plus A transpose itself. That is the definition of symmetric matrix. Means this is a symmetric matrix. Now we'll check for the skew symmetric matrix. Suppose we take C as A minus A transpose. I will prove that A minus A transpose is skew symmetric. So we'll take transpose of A minus A transpose. We have taken over here. Now you apply this one property, the same property in this step. So it will be A transpose minus of A transpose whole transpose. This thing is A only. So now it is A transpose minus A. You can take negative sign common. So now it is negative of A minus A transpose, you can see. So we got this C transpose is equal to negative of C. And that is the definition of a symmetric matrix. So the difference of two matrices, a difference of a matrix and a transpose is symmetric matrix. Theorem 2 is applicable in many questions in the exercise. We'll use this, and in sometimes in the CBSE board examination, you can get the question based on this property. How to express a given matrix as a sum of symmetric and symmetric matrix. How to express a given matrix as a sum of symmetric and symmetric matrix. That I will explain. Okay, express a matrix as a sum of symmetric and symmetric matrix. I will explain you the total method. See how to express it. Suppose any matrix A is given. It is asked to express this as a sum of symmetric and symmetric matrix. So I will write it as 2A by 2. You will follow these steps. Now this 2A can be written as half of A plus A transpose. I will add A transpose and I will subtract A transpose. Now this thing should be clear to you because I have broken this 2A as A and A, add A transpose and subtract A transpose. Now you break it into two parts. It is half of A plus A transpose plus half of A minus A transpose. So we can express a matrix A as half of A plus A transpose plus half of A minus A transpose. We already know using theorem 1 that this is a symmetric and this is a symmetric matrix. So in this way now we are able to express a given matrix A as sum of symmetric and symmetric matrix. So whenever it is asked to express a matrix A as a sum of symmetric and symmetric matrix, we'll follow this method. We'll write A is equal to half of A plus A transpose plus half of A minus A transpose. And you can further solve the questions based on it. Suppose the question is given, this is the question, express this matrix as a sum of symmetric and symmetric matrix. So quite important question. So this is given B. So in first step we'll get B transpose. We'll write P equal to half of B plus B transpose. We'll add B and B transpose. You add both these two. We got this thing, half of B plus B transpose. This is a symmetric matrix. Need not to prove it. This P is a symmetric matrix because using theorem we already know that half of B plus B transpose will be a symmetric matrix. Now we'll write Q is equal to half of B minus B transpose. So half of, you subtract this and this, you will get this one particular matrix. Calculation is not done over here. You can do yourself. B minus B transpose, you will get this much. So whatever matrix you get, it is skew symmetric. So we can express this B as sum of this plus this. All right. Means B we have written it as B is equal to nothing. It is equal to, I can write it as P plus Q, or I can write it as half of B plus B transpose plus half of B minus B transpose. This is a symmetric and this is a skew symmetric. In this way, we are able to express a given matrix as the sum of symmetric and a skew symmetric matrix. All right. So on the basis of this, we will do the exercise 3.3. So just we will discuss exercise 3.3. You see, I will explain the solutions of exercise 3.3 from the NCERT. So it's a very simple exercise because symmetric and skew symmetric matrix we have already done. So if we take the transpose of a given matrix and it is equal to matrix itself, we can say it is a symmetric matrix. And if we take the transpose of matrix, it is negative of matrix itself, we will say it is a skew symmetric matrix. So now we'll do next one exercise. Previous two exercise we have done the multiplication, etc. So now come to the exercise 3.3. Your question number 1 is given. So Not much is there. It is given that find the transpose of each of the following. So 5.5 it is given. It is a column matrix. So you can just convert this into transpose, means you convert the column into row. Second question, your first row 1 and minus will become the first column, and 2 and 3 will become the second column. In this, the first row minus 1, 5 and 6 will become the first column. Root 3, 5 and 6 will become the second column. Actually, some misprint is there in this. Actually, third row is also there. That is 2, 3 and minus 1. Question number 2 is given. A and B are given. It is asked to prove that A plus B transpose is equal to A transpose B transpose. A minus transpose is equal to A transpose minus B transpose. So nothing is there. First, you will calculate left hand side. So to get left hand side, you add both these two and then you take the transpose of that. So first we'll add A and B. You will get this as the result. You just add this. Okay. Add each individual element to the corresponding elements. A plus B. So we got A plus B is equal to this much. Now you take the transpose of this. So while taking transpose, this first row will become first column. Second row will become second column. Third row will become third column. It is A plus B transpose. Now you have to prove it is equal to A transpose plus B transpose. So first of all, we'll write A transpose. This is A transpose, you see. And this is B transpose. Add both these two. So you are going to get the same thing which you got in this step, that is A plus B whole transpose is equal to A transpose plus B transpose. The second part is also similar. You have to find A minus B transpose. So first you calculate A minus B. This is A, this is B. You will take the difference of the corresponding elements. So we are going to get this as A minus B. Now you take the transpose of this, means change its rows into columns. So its first row will be first column. Like this we have A minus B whole transpose. Now you have to find A transpose minus B transpose. So subtract these two. So on subtracting, you are going to get the same matrix which you got in this step. So in this way we can prove it. Question number 3. A transpose is given and B is given. We want to prove that A plus B whole transpose is equal to A transpose plus B transpose. So in this question, you first calculate B transpose and take transpose of this, you will get A. Okay. So you to get A, take transpose of this. On taking transpose of this, we get A and you get B transpose, because these things will be required to calculate this thing. Now you want to get A plus B. So you add this A in this B. Both have same order, so we can add these two. Add the corresponding elements, you will get this matrix. Now you take the transpose of this. So convert first row into first column, second row into second column. You have A plus B whole transpose. Now you add A transpose and B transpose. This is A transpose and B transpose. So on adding A transpose, in B transpose, you are going to get this thing. So both are equal. So in this way, we can say A plus B transpose is equal to A transpose plus B transpose. In similar way, you can write A minus B transpose is equal to A transpose minus B transpose. So solution, you can easily do it. You take A minus B, then you subtract A transpose from B transpose from A transpose, and you will get the same thing. Question number 4. A transpose and B is given. It is asked to find A plus 2B whole transpose. So question is quite simple. First you get A. So on again taking transpose of this using this property, you will get A. So it will be minus 2, 3 will be the first column and 1, 2 will be the second column. Now you have A, get 2B. 2B means you will multiply all the elements of B by 2. So now you get A plus 2B. It is minus 4, 1, 5, 6. You want to get A plus 2B transpose. So take the transpose of this. Means convert this first row into first column and second row into second column. Question 5. For any two matrices A and B, verify AB all transpose is equal to B transpose A transpose. So these I will explain the next classes, although you can try yourself. Thank you for today's class.